Hello again. We are back with the Nintendo Switch. At the moment, I try to check this to data line. Fair time. They passing through, so that's a good one. Now let's see from the legs. This is 2, 3, 4, 5, 6, and 7. Counting on the USB-C port. And yep, it's getting through, so this should be fine. Now, sometimes we have a short on the power management IC, so I quickly check the capacitors here. If you have a bad capacitors or a bad chip here, then that could cause this issue when it's 5 volt is going up, but after it's nothing. And you have a good chance if the fuse got blown, so double check this one. In our case, it looks alright, to be honest. So, okay, now I just double checked the legs. Everything is connected. Everything is fine. I saw a little movement, so just in case, we're going through this again, because obviously if we have a bad connection, then it's not gonna work, isn't it? Now USB-C port on the Nintendo Switch is can melt inside, so if you heat up more than once, it's a chance it might get melted inside. In that case, usually you can't plug the USB-C port in completely, but in this case, we was able. So 5 volt is going in, and this 0.09 ampere. So our next suspect is definitely the M92 chip, because this should negotiate with the charger to provide more than 5 voltage. And after sort out the things with the battery management IC, how much you need the battery, etc. Now here we have a 10 ohm low resistance still, the other one is 82, so that alright now. We made some progress. These capacitors looks alright. Now if you have one capacitor is bad, then probably the capacitor is bad. If you have more than one, then it could be the chip. If it's completely short, probably the capacitors, but if it's low resistance, usually the chip. Oh no.
Please, not green. Oh, damn.
Alright, so we have a bad M92 chip. Usual flux. Heat up. Get off the chip. Now, this chip is completely grounded underneath, so it's have a big ground plate. And this is why it needs a little bit more time, more heat to get off. So you can't, I mean, I tried 350 Celsius before, that one didn't work for me. I tried much more air, like 160 liter. In that case, you can blow off the tiny capacitor. So what is work for me is 450 Celsius or 400 Celsius and around 90 to 100, 120 liter. Basically, if it's a lower temperature, you need more air pressure. If it's a higher temperature, then you need less. Obviously, when you heat up, is a little bit of fiddly work, but yeah. after a while it's get to the right place. Now after this you have to check all the legs are connected properly. You can see when the metal is the solder is coming in a nice angle, then it's good. Oops, okay, we have to fix that one. But you can see from the bottom the first 5 leg is not connected well, so we have the metal plate, you know, the PCB, we have the chip, but the connection between them is minimal. So what I'm usually do, I'm using a little flux and solder paste combo, and this occasion I forget to put fresh flux on it, so it's a little bit harder. I can sort that out. Sorry about the shaking, accidentally I hit the microscope. So a little flux, you put some solder paste on it. This doesn't have to be on the right, exactly the right spot. Don't worry, when we heat up, it's gonna find a way. If it's just 1 or 2 legs, then usually I'm using the solder iron. But like in this case, we have multiple legs, then yeah, I just use this method. This one is work for me. Unfortunately, because we're using the solder paste, after we have to tidy up very nicely, but we get there. All right, let's get a better look. All right, let's heat up, and you can see as the solder paste is melting, it's gonna find the right place. It's just flowing, and we can sort out that tiny resistor. I don't know what is that. You moving the air around a little bit, the little soldier balls try to stick to the greater mass. If it doesn't find anything after, we can wash up. We're just using isopropyl alcohol, of course. You need a hard brush, sometimes a little help with a tweezer, but basically every excess is just gonna come off nicely. With the tweezer you can feel if it have the right angle. We still have 2 sides that we have to work on it. There's not much left here, so we're just going through with the solder iron. It's much easier if you have a hot pad underneath. Otherwise it's really cooling off very quickly, but you can manage it without it. I did. Obviously signal lines are much easier than 5 voltage rails or ground plates. That one's a little bit harder. If you can't manage to make an ice soldier, just heat up a little bit, like 200 Celsius with the hot air, and after try to solder. It's much easier that way. I'm just going through all the places where I can see any issues. Just a few seconds touch, and it should be fine now. After we give a nice clean, we don't want little soldering balls wandering around making shorts, and after you have to replace the chip again. Alright, it's time to test again. So we're gonna plug in our little tester. In this case, I left on the other side of the line. Unfortunately, it's only 5 volt is going in, so still not a happy one. So I'm gonna wandering around a little bit, checking if the voltage is going up to the M92 chip. So I can see the 5 volt is coming in, but basically nothing greater is coming out. So its negotiation is not happening. Now a fellow YouTuber showed that in that case, the only thing what is helped him, it was to replace the B9, the B battery management chip. What we already checked, it was no shorted capacitor around here, but that was his case as well. So maybe it's time to replace this one and see if it do any difference. So I clean up a little bit first. This is the BQ24193. I'm using a little heat pad to cover the battery connection because obviously it needs some heat to remove the chip, and that one can melt very easily. It's happened with me before, so since then I'm using these heat pads. Basically, we're taking off from all the TV main boards. They have plenty of them and very thick and can handle higher temperature. And I usually clean up around this area if it's dirty, because we don't want any dirt to burn and make problems for us when we try to insert the new chip. We try to make this quick and efficient as it possible. So again, we heat up. Now for this one, you need a little bit less temperature, so 350, 400 Celsius is usually it's enough. We still have a ground plate, but it's a much smaller chip. Yeah, unfortunately, I knocked off a few things, but we can sort this out. It's just an average Wednesday, isn't it? Okay, let's let it cool down. You see the battery connection survived, so that's a good one. Once everything is cooled down, we can move to the next step. Check obviously all the sides. These are good. These are good. Plenty of soldier there. Yeah, some side is not really easy to see, but we can get around and get a nice angle. Okay, so that 2 legs is not really perfect. Let's sort that out. That's the 2 what I'm talking about. You see next to the other ones, those have this nice angle. These are basically dry. Again, tiny bit of flux, tiny bit of solder paste. Don't worry if it looks a little bit too much. As it starts floating, you will see it's when it's melt, it's basically take much less space. You see, few seconds heat up, and it's perfect. Now you can see very closely when it's floating around. Sometimes it's stuck to the wrong place, so let's clean this up, and after we're good. Okay, so 5 volt is going in, but after nothing coming down. We're still getting 5 voltage and the same ampere. So I'm just going through one more time. Basically one thing is left to make the connection. So basically in this USB-C port you have the ground connections on the two sides, first and the last one. You have the 5 voltage, which you can see that to the 4th and 10 legs, and the rest is to communicate the charger. So if it's something wrong there, then the communication is not going through with the charger. So I put some extra solder paste, a little bit thicker, to make sure it's going in both sides nicely. I heat up from the bottom. If you don't have a hot plate, then you use hot air, and I'm using the solder at the same time. And fresh flux, and let it burn, baby, let it burn. There we go. You push down against the board with a tweezer just to make sure you get the best connection. So just to get through, we replaced the charging port on this one at least twice. We replaced the M92 chip once, and we replaced the battery management IC. And yes, finally 11 volt. So it's connected to the charger. Obviously it's not going to go any further because it's need the battery connect and everything. We're gonna hook it up and see what's going on, but I just want to show you this is the normal thing when it's 1176 volt is going through. It's basically 0 milliampere or very close to 0. It's perfectly normal, but now it's charging and I can finish it and give back to the customer. Thank you for watching. I hope you learned something today. See you next time.